Okay, in this video we're going to explore our three elementary row operations when it comes to matrix operations. Basically, these are operations that we can perform with matrices such that the new matrix that we get after undergoing that transformation is the same kind of matrix as the original. Now, it's not the same, but we say it's row equivalent, okay? So the first part we're going to start with is this bottom vocabulary phrase here. It says row equivalent. We say two matrices are row equivalent if one matrix can be obtained from the other matrix by a sequence of elementary row operations. And so for our elementary row operations, I'm going to be working with the same 3 by 3 matrix that you see in each of these cases. But what I'm going to do is just basically illustrate the different row operations and how we would write them, okay? So in terms of swapping two rows or interchanging two rows, we're going to say that in terms of where our matrix is organized right now, we're going to refer to these as row 1, row 2, and row 3. You don't have to use a subscript. You could just write row 1, row 2, row 3. But basically, maybe what I want to do is switch row 1 with row 3. And because it affects both row 1 and row 3, I don't have to write it next to one or the other. But basically, I'm going to write it next to row number 1. And what you'll see is if I were to swap these two rows right here, basically the new first row would be -1, or sorry, 1, -2, and 3. And the bottom row would now become this 2, -5, and 5, with the middle row being -1, 3, and 0. So this is a very basic, I guess, row operation, but one that we use a lot, especially when we want to use Gaussian elimination. We got a 1 in the top left corner, which was easy to do with switching rows. Now, multiplying a row by a non-zero constant, or we're going to refer to this non-zero constant as what we call a scalar. What it does is it scales rows. This is a C here, so a scalar. And what we're going to do in this instance, I suppose it doesn't really matter what we do. So let's do this. Let's do -2 times row number 3. And you'll notice that I wrote it next to row number 3 just to kind of give you an indication that that's what I'm changing here. So the nice thing about matrices is you don't have to rewrite, say if you're working with systems, all the letters in the system. You can just write these values here. And if I negative doubled the third row, I get -2, +4, and a -6 here on the third row. But this would be our new row equivalent matrix to the original here. And then lastly, we say add a multiple of a row to another row. Now the interesting thing here is this. It says add a multiple of a row onto another row. It doesn't say anything about changing the initial row. So let's do this. Let's take 3 times our row 1 and we'll add it to row 2. How about we do that? So we say 3 times row 1 plus row 2. And I'm going to write this next to row 2 because it is the one that I am affecting. So the nice thing about this is, check this out. You're going to rewrite all of your values here. It certainly doesn't change any of those, okay? So really all we're doing is we're taking 3 times all of these values right here, and we're going to add it onto the second row. So we'll do some mental math here, but 3 times 2 would be 6, and 6 plus a -1 would be a 5. And then 3 times -5 would be -15, but a -15 plus a +3 is a -12. And then 3 times our 5 here is 15, plus 0 is 15. So this would be our new row equivalent matrix to the original matrix where we added 3 times the first row to the second row. So in terms of row operations, you know, I've got a couple of examples here where all I really want to do is identify what was the row operation that occurred, and especially in this example, what this indicated value would be or have to be. So when I look at this, I notice that the second row here just didn't change whatsoever. So it may be the case that we multiplied the first row by a number to get this first row right here. And so if I ask this question, I say, what can I take times 3 to get 1? Well, anything times its reciprocal would be 1. So if I took the first row times 1/3, my question is that what happened? So let's go take a look at this. If I take 3 times 1/3, I would get 1. If I take 8 times a third, I certainly would get 8/3. So it looks like that this is the row operation here. So this is our operation. And then the idea here would be to indicate, well, then what does this unknown value have to be? Well, what we did was we took this 6 times a third, and if you do that, you get this value is out to be 2. It comes out to be 2. So looking at the second instance over here, again, you know, looking for things that didn't change. I noticed that my first row here didn't change from my, you know, down here didn't change from my first row up here. So looking at what else is different, well, we say now what's different, pardon me, is that the second row is different. And I notice instantly, this is just me, but -4 becoming a 5 and 7 becoming a -5 isn't that dramatic. But I'd say 3 becoming a 0, that's pretty legit. So now I know this. I didn't multiply the whole second row by 0 to get this 3 to be 0, because otherwise these would be zeros also. So it's not scaling that we did. We didn't switch any rows. So what we must have done was added a multiple of row 1 to row 2. So I would say that my row operation here is we added something times row 1 plus row 2. The question is, what did we take times row 1 and add to row 2 to get this to be a 0? And so about the only thing I can think of adding to a 3 to get a 0 would be a -3. So here comes the question. What could I take times this -1 to get a -3, and I suppose it would be just a 3 here. So what we must have done is we must have tripled the first row and added it to the second row. This must be our operation right here. With respect to the other values, let's see if we got what we needed to get here. So 3 times this right here would be 9, and 9 plus 4, that would give us a 5. And if we were to take 3 times our -4 is -12, -12 plus a +7 is a -5. So this indeed was the operation, and there were no unknown values to indicate here. So we're going to use these elementary row operations in the next video to talk about how to put something into row echelon form. Cheers.